Okay, let's look at section 3.1. This section talks about two proof techniques. First one is called trivial proof, and the second one is called the vacuous proof. All right, so let's look at the trivial proof. All right, our goal is to prove this statement. For all x in S, P of x implies Q of x. All right, so let's try to do that. All right, for trivial proof, we need to pay attention to this. When conclusion Q is true, every time conclusion is true, implication is always true, right? So we're going to use this fact to establish this statement. All right, so let's do that. So we're kind of ignoring the if part, but if we can establish, so if you can prove that for all x in the set S, if you can establish that the Q of x is true, then we would have the true implication, right? So here's an example, right? So here's a statement. For all x, which is a real number, if x is greater than or equal to 0, then x squared plus 2x plus 1 is greater than equal to 0, right? So let's prove that. So here's the proof, right? So let's say for all real number x, right? I'm going to ignore the hypotheses. I'm going to just say conclusion is always true, right? X squared plus 2 of x plus 1 can be factored out as x plus 1 by completing the square. So x plus 1 squared, right? Then since it's squared, it's already greater than or equal to 0, right? Then we're done. We actually proved that the conclusion is always true for all real number x, right? This square indicates the end of the proof, right? This kind of proof is called the trivial proof. So we basically ignore the hypotheses, but we just try to show that the conclusion is always true, right? So that's called the trivial proof, right? The next one, if you pay attention to the hypotheses, right? Every time hypothesis is false, you will actually get a true implication. So we're going to use this fact to write a proof, right? So this is called the vacuous proof. For vacuous proof, what we do is we will try to prove that for all x in S, right, the hypothesis P of x is actually false. Oops, sorry. False. Right? So let's do that. So here's an example. So it says that for all real number x, if x squared is less than -1, then x squared plus 1 is less than 0. Right? This is actually a true statement. Right? So let's try to show that. So here's the proof. Right? So we know that for all real number x, right, x squared is actually greater than equal to 0 because of the square, right? Which means that x squared cannot be less than -1, right? Then that will prove that this implication is true, because for all real number x, the hypothesis is always false. Therefore, implication is true, right? So this is called the vacuous proof. So for trivial proof, you try to establish that the conclusion is always true, right? For vacuous proof, you try to establish that the hypothesis is always false, right? So those are the two proofs that we look at, right? That's it. I hope that this was clear.